Hello everyone. Previously we had discussed on the topic simple queue, right? So today we'll be discussing on the topic stack, right? So let's get into the definition part here. What does the definition part say here? A stack is a linear data structure. So a stack is a linear data structure that follows LIFO order, where the last element added is removed first, right? LIFO order in the sense last in, first out, right? So where the last element added is removed first. We know this one, right? So it is opposite to the queue. It is opposite to the queue. And stacks can be implemented using lists or DQ in Python. Again, stacks can be implemented using lists or DQ in Python, right? Simple, very simple. Let's see the same thing with a very simple example, man. So I'll just go with stack here. So variable name, I'll just initialize this one with a empty array. So I'll just go with stack dot, I'll just go with append operation that the stack provides. So I'll just go with A here. Same thing. Let me copy this one again. Let me copy this one again. Right. So this one, let me change from A to B. Let me change from A to C. Right. So we have appended A, B, and C to the stack. Right. So now let me print something. I'll just go with a print here. Hmm, let me give something here like stack within the strings and let me pass stack here, right? So this is fine. Now let me go with the print here. So this one I'll just give popped here. This is fine. Let me pass something, nothing but stack dot pop, stack dot pop. This is fine. Yeah, this is fine, man. Let me go with the print again here. So this one will be after pop. This is fine. Uh, stack, right? So stack. This is fine. Yep. So we are done with the stack part. We are done with the stack part. So what does the stack definition say? It is the LIFO structure where last added element is removed first, right? So this one I didn't. We went for this one basically. Mm, 1 second. Stacks can be implemented using lists or DQ in Python. I don't think so, right? So this one, 1 second, man. This one I have given 1 second. So let me remove this one. Sorry for this. Uh, I did explain the same thing, I think. Sorry. That wasn't the thing basically, right? So just forget that one. Just remember this one, man. A stack is a LIFO structure where the last added element is removed first. So I copied that one from somewhere, I think. Sorry. This one, let's go with a simple explanation here. Python lists can be used as stacks using append and pop. Just remember this one. For the stacks, Python lists can be used as stacks using append and pop. Just remember this one, right? So here, the output that we need to get here is this one, stack A, B, and C, because we have given stack, right? So stack A, we are appending A, B, and C, right? One by one. Stack A, comma B, comma C, we have to get. Then we are popping. So popped C. So the last element will get popped, right? So last in, first out. Stack follows last in, first out. See here, a stack is a linear data structure that follows LIFO order, nothing but last in, first out, right? So this one is last and it has to be popped first. Basically, when I give stack.pop, so we have to get the output first C, popped C. So then again I'm giving here after pop I'm just printing stack here, so we have to get the output A and B. C is popped, so we have to get the output A and B, right? So let's check the same. I'll just give your Python. mm, Let me right click, rename, copy the file name dot py, right? So see here, first we are appending A, B, and C to the stack. This is fine. We have popped C. We have popped C. Then after pop, we are printing the elements that are present in the stack, nothing but A, B, right? So this is it for the stack. Very simple one. Basically, let me summarize whatever we have learned so far. So stacks follow LIFO principle, nothing but last in first out principle, and they are ideal for undo operations and recursion simulation, right? So again, stacks follow LIFO principle, nothing but last in first out principle, and they are ideal for undo operations and recursion simulation, right? So we are done with the stack part. We are done with the stack part. So let me close this one entirely. Yeah, next we'll be discussing on the graph, right? So next we'll be discussing on the graph. For now, this is it. Thanks for watching, guys.